Welcome everybody, we got this question to integrate integral negative pi over 2 to pi over 2 dx over 1 positive e raised to the power of x times sine raised to the power of 6x positive cos raised to the power of 6x. Now let me take this as 1, and we know this property. Integral a to b f of x dx can be rewritten as integral a to b f of a positive b negative x times dx. So therefore one can be rewritten as I is equal to integral negative pi over 2 to pi over 2 dx over. Now let me write this value for e raised to the power of x. E raised to the power of x is going to be pi over 2 positive of negative pi over 2, right? So I'll start with negative pi over 2, I add pi over 2, and then this has to be followed with a negative x. Now negative positive gets cancelled, you get e raised to the power of negative x. So it's sufficient for me to just place that value, e raised to the power of negative x. So that is followed by, now clearly these are all even powers, right? So we are not going to have any change in that. So it's going to be sine raised to the power of 6x positive cos raised to the power of 6x. Fair enough. So we have got this 2. Now what I will do is I would want to add probably 1 with 2. If I were to do that, I will have to deal with this denominator. So let me get rid of that. So it's negative pi over 2 to pi over 2 dx over 1 positive 1 over e raised to the power of x times sine raised to the power of 6x positive cos raised to the power of 6x. So this is going to be integral negative pi over 2 to pi over 2. I can flip it, this goes to the numerator. So you have e raised to the power of x times dx divided by, this is going to be e raised to the power of x, right? So I will write it as e raised to 1 positive e raised to the power of x times sine raised to the power of 6x positive cos raised to the power of 6x. Now let this be as 3, and I have an I here. So what I'm going to do is I'm going to add 1 and 3. We get, so this is 2 times I is equal to, now this is 1 is added with 3. The denominators are one and the same. So we're going to get 1 positive e raised to the power of x times the dx divided by 1 positive e raised to the power of x times sine raised to the power of 6x positive cos raised to the power of 6x. Now this and this gets cancelled, giving me 2 times I is equal to integral dx over sine raised to the power of 6x positive cos raised to the power of 6x. Now the limits are negative pi over 2 to pi over 2, negative pi over 2 to pi over 2. Okay, fair enough. So we have got that. So let me move on to the next side. So you have 2 times I is equal to negative pi over 2 to pi over 2 dx divided by, I'm going to write sine raised to the power of 6x as sine raised to the power of 2x raised to the power of 3. Fair enough, right? So this is followed by cos raised to the power of 2x, this in turn is raised to the power of 3. So this is what I've got. Now if I were to take a to be as sine squared x and b to be as cos squared x, then I got a cubed positive b cubed, which has got a formula of a positive b whole cube negative 3ab times a positive b. Okay, so if I were to use this formula, then my sine squared x raised to the power of 3 positive cos squared x raised to the power of 3 is going to be, in place of a is sine squared x, in place of b cos squared x raised to the power of 3 negative, in place of a is sine squared x, b is cos squared x multiplied with a is sine squared x and b is cos squared x. Now we know that sine squared x positive cos squared x is equal to 1, right? So this becomes equal to 1 negative 3 times sine squared x times cos squared x. This is what we got. So if I were to take this as 4, so therefore 4 is now rewritten as integral negative pi over 2 to pi over 2 dx divided by, I already showed you how to simplify this in this fashion. So what we have to do is replace the denominator with this quantity, 1 negative 3 times sine squared x times cos squared x. Now what I wish to do is I want to get rid of this cos squared x. So if I were to get rid of this cos squared x, I need to divide by cos squared x. So if I divide by cos squared x, before I could divide this by cos squared x, what I wish to do is I will multiply by 4 the numerator and denominator. So this is equal to negative pi over 2 to pi over 2, 4 times the dx divided by 4 times of 1 negative 3 times sine squared x cos squared x. I'm doing all those things so that we are arriving at a certain point where integration becomes lucid. So this is equal to negative pi over 2 to pi over 2, right? I'm just rewriting it. But in this case, what I'm going to do is I'm going to distribute 4. I'll distribute 4, I get 4 negative 3 times of 4 times sine squared x times cos squared x. This is what I am getting. Now what I have to do now here to use my sine 2x formula, which is nothing but 2 times sine x and cos x. Now if I were to rewrite 4 times sine squared x times cos squared x as 2 times sine x cos x the whole squared, is it okay? Can I do that? Of course I can do that, but 2 times sine x cos x is nothing but sine 2x. This is raised to the power of 2. Now if I were to bring this in, this is going to be sine squared 2x, right? So in place of this, I'm going to use this. So this is equal to integral negative pi over 2 to pi over 2. I'm going to take 4 out, so it's going to be dx over. Now 4 negative 3 times of, what do I have? I got sine squared 2x. Okay, so now the question comes to get rid of this. How do I get rid of this? I'm going to divide the numerator and the denominator by cos squared 2x. So if I were to do that, this is going to be 4 times dx over cos squared 2x divided by 4 over cos squared 2x negative 3 over sine squared 2x divided by cos squared 2x. This is 4 times, of course the limits are pi over 2 to pi over 2, negative pi over 2 to pi over 2. Now 1 over cos x is secant x, right? So 1 over cos squared x is secant squared x. 1 over cos squared 2x is going to be secant squared 2x times the dx divided by, this is going to be 4 times of secant squared 2x negative 3 times of sine squared 2x over cos squared 2x, that's what? Tan squared 2x. Okay, fair enough. So this is what we have arrived at. Now everything is squared, 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 right? So I can rewrite this as 4 times of 2 times integral 0 to pi over 2 of secant squared 2x divided by 4 times of secant squared 2x negative 3 times of tan squared 2x times the dx. Now what I wish to do is I want to make the following substitution. Secant squared x is equal to 1 positive tan squared x, right? So I'm not going to touch this in the numerator, but I'm going to refine this in the denominator. So 4 times of 2 times integral 0 to pi over 2 secant squared 2x divided by 4 times of 1 positive tan squared 2x negative 3 times of tan squared 2x times the dx. Now 4 times tan squared 2x, 3 times tan squared 2x. So they get operated with. So that one would give us a cumulative effect of 1 tan squared 2x. So this is going to be secant squared 2x divided by 4 positive. I have just tan squared 2x. This is what I've got. Okay. Of course, we got the dx. So now what I wish to do is I will have to make the following substitution. So 4 times or 2 times integral 0 to pi over 2 secant squared 2x dx divided by 4 positive tan squared 2x. So this is exactly what we have, and on the left we have 2 times I, right? So 2 times I is actually following us from here. Okay. So we have 2 times I. Now what I wish to do is I would like to split this limit and rewrite it as 4 times of 2 times integral 0 to pi over 4 secant squared 2x divided by 4 positive tan squared 2x times dx. Now let me take tan 2x to be equal to t. If tan 2x is equal to t, differentiation of tan 2x is going to be secant squared 2x and the coefficient of x is 2 times dx. This is equal to dt. Now when x is equal to 0, what happens to t? And x is equal to 0, t will be equal to 0. When x is equal to pi over 4, I have tan 90, so t will be equal to infinity. Okay, so that is a very important substitution or the change of limits you will have to take into account. So this is going to be equal to 4 times of 2 times of 2 times integral 0 to infinity secant squared 2x. Now you already have a 2 here, so I'm going to take in this 2 inside. So that is going to give me a dt divided by 4. I'm going to write it as 2 squared. Now tan squared 2x, tan 2x is t, so this is going to be t squared. So if I were to rewrite this, I'm going to get 4 times of 2 times integral dt. This is similar to integral dx over x squared positive a squared, which is 1 over a tan inverse of x over a positive c. So this is going to give us 1 over 2 tan inverse of x over a t over 2, right? The limits are 0 to infinity. So 2 gets cancelled, you have 4. Now tan inverse of infinity divide, so you need to have the tan inverse of infinity. So if I were to substitute infinity here, that would give us pi over 2, isn't it? Because tan inverse of infinity is pi over 2. So this value will produce pi over 2 followed by 0. So I have 4 times pi over 2. So that means 2 divides here 2 times, so you have 2 pi. But on the left hand side I have 2i. So this means 2i is equal to 2 pi. 2 gets cancelled. This means I is equal to pi. So this is a solution for this beautiful question. Please like, share and subscribe. Thank you everybody.